Chris Ray with a quick summary of some things we've learned from studying birds in the national parks of the Pacific Northwest. This talk was originally given as part of the 2025 North Coast and Cascades Science Days. I conducted these analyses with the help of many colleagues at the Institute for Bird Populations and the North Coast and Cascades Inventory and Monitoring Network. In 2025, we began monitoring birds at hundreds of permanent points spread across 5 parks, including 3 large mountain parks, Olympic, Mount Rainier, and North Cascades, and 2 small lowland parks, San Juan Island and Lewis and Clark Historical Parks. Our goal was to analyze trends in a large sample of bird species identified by our trained observers. We estimated trends in population density from 2005 to 2023 for about 60 species. We see here our estimates for the sooty grouse, with population density on the y-axis and year on the x-axis. Colors and symbols differentiate trends among the 3 mountain parks where this grouse was commonly detected. Although density appeared to decline a bit over the long term, there was enough year-to-year fluctuation that long-term trends were estimated with low confidence, as indicated by dashed trend lines. Annual fluctuations tended to be explained by climate. For many bird species in these parks, population density increased after warm spring temperatures and decreased after winters with higher snowfall. Most species have remained stable in these parks. Here we see population density on the y-axis and year on the x-axis for 3 species in the 3 mountain parks. Northern flicker tended to increase in all 3 parks, but statistical confidence in these trends was low. Clark's nutcracker appeared to decline in all 3 parks, but also with low confidence. For both northern flicker and Clark's nutcracker, confidence in trend estimates was curbed by a few very rapid fluctuations in density. In contrast, dark-eyed junco trends were positive and consistent, which resulted in high confidence in those trends, indicated by solid trend lines for North Cascades and Olympic. More broadly, here's a quick peek at 16 randomly selected species, with each trend in density averaged across the mountain parks where that species occurs. None of these trends were decreasing, and more than 1/3 were increasing with high confidence. Long story short, the bird populations we analyzed were overwhelmingly stable or increasing in the 3 mountain parks, and the same was true for the 2 lowland parks. Here we see trends in 15 randomly selected species from Lewis and Clark. All appeared stable or increasing. In these simplified plots, asterisks indicate trends supported with high confidence. One mechanism that might explain the resilience of these populations is that their distributions might be shifting as individuals track favorable conditions. For example, populations in the mountain parks might be shifting upslope as temperatures rise and winter snowpack declines. So our analyses were designed to look for evidence that the relationship between density and elevation has shifted over time. Preliminary analyses of 57 species in the 3 mountain parks showed evidence of shifting distributions for 35 species. Here we see the mean elevation of western flycatcher detections on the y-axis and year on the x-axis. Populations of western flycatcher appeared to be moving upslope over time in all 3 mountain parks, and there was high confidence in those upslope movements in both Mount Rainier and Olympic. But for many species, the pattern was more complex. Some species appeared to move upslope in one park but downslope in another, like the yellow-rumped warbler and the brown creeper. And downslope shifts were supported about as often as upslope shifts. Mountain chickadee trended upslope in at least one of the 2 parks where it was common enough to support our analyses, while western wood peeweet trended downslope in the only mountain park where it was common. Finally, trends in Olympic National Park were more likely to be estimated with high confidence. Dark-eyed junco shifted downslope only in that one park. So many bird populations were stable and shifted up or down slope in the mountain parks over the past 2 decades. But let's recall that populations were also stable in the lowland parks. And in the lowland parks, birds don't have access to a strong elevational gradient. This suggests that the elevational shifts we detected in mountain parks might not fully explain the stability of those populations. Thanks to my colleagues and the many field assistants at the Institute for Bird Populations for gathering these data, and to the NCCN I&M for continued opportunities to monitor and study these birds.